So you can understand this is something like a diet, right? This is all about making a new food item, nutritious one. Okay, they are going to mix up mm, some two types of food item in order to make another mixture. So something related with the diet. So the kind of problems are called diet problems. Okay, diet problems. And similarly, there are some other categories of problem called manufacturing problems. For example, in the, some bulbs are manufactured, some tubes are manufactured. So something related with manufacturing. Hmm. For manufacturing a bulb, it requires 2 hours of electrician's time and 3 hours of machine time, like that. So how many bulbs and tubes are to be made so as to get maximum profit? So such kind of problems are categorized or taken under the head manufacturing problems, and the solutions are the same, but they are to in order to distinguish, we call them by these names. Diet problems and some other kind of problems are also there, transportation problem, etc. Now let us come back again to this question. Reshma wishes to mix. So while reading, we'll try to note down what are the things. Okay, we'll just make a table. Hmm. We'll just make a table. We don't know so far anything about the question. Reshma wishes to mix two types of food P and Q. So P and Q, food type. P type is there, Q is there. They are going to mix up P and Q in such a way that the vitamin content. Otherwise, let me make here. It should be a little like this. Okay, for columns P and Q. Now what? You continue reading. The vitamin contents of the mixture contain at least 8 units of vitamin A. So we have to write vitamin A and vitamin B. Okay, let us note down vitamin B. And maximum vitamin A, what is it? At least 8 units. Minimum must be 8 units. Vitamin A. Vitamin B, vitamin A, and 11 units of vitamin B. Vitamin 11. Okay. Now again continue reading. Food P costs 60 rupees. Cost is also required. Cost. Food P costs 60 rupees. Okay, 60. And food Q cost 80 rupees. 80. 80 rupees. Food P contains 3 units per kg of vitamin A. P contains per unit 3 kg of vitamin A and 5 units per kg. 5 units per kg of vitamin B. 5. Here it is 5. P contains per unit 3 per unit of P. Food P contains 3 units per kg. 3 units per kg. 5 units per kg of vitamin B. Okay. So while writing, you have to take care. While food Q contains what? 4 units of vitamin A and 2 units of vitamin. 2 units means 2 units per kg. 2 units per kg vitamin B. 2 units. Determine the minimum cost of the mixture. Minimum cost of the mixture. So we are going to mix up P and Q. In what ratio or what quantity we need to mix up P and Q, that we don't know. So unknown quantities are taken as X. Correct. I decided to take X units of P and Y units of Q. Okay. Now what? What is the total vitamin A then? 3x. Per unit 3 kilo. X unit 3x. So you got, let me erase this. Okay. Okay. 3x plus 4y. This is the total vitamin content of the mixture. We are going to mix X units of P and Y units of Q. So mixture contains 3x plus 4y vitamin A. This is the total vitamin A content of mixture, and it is given that should be at least, take care, at least minimum 8. So it must be greater than or equal to 8. Okay. And what about this B5x 5x plus 5x plus 2y? This is the total what vitamin B content. So in 1 unit of P 5, then X unit of P, then 5x total B vitamin. What about the vitamin B here? 2y. So total vitamin B 5x plus 2y. This is the total vitamin B, and it is given that vitamin 11 units of vitamin B minimum. Minimum at least means minimum it should be 11. It can be 12, it can be 13, like that, greater than or equal to 11. Right? Have you understood this? This is what is the solution. This is the solution. This is what I told you now. Okay. 3x plus 4y greater than or equal to 8. 5x plus 2y greater than or equal to 11. So what is the cost? As per our question, the cost should be minimized. What is the minimum cost? Minimum cost. So finally, what is cost? Cost can be calculated like this. And as far as this question is concerned, this function is called objective function. Okay. Cost is 60 for this. Okay. So x unit we are going to take, and y unit we are going to take this. So total cost for x unit, x into 60. Total cost for y units 80y. So z is equal to 60x plus 80y. So mathematical formulation, as I said, this is the structure of mathematical formulation of the problem. Minimize. Either we can minimize, or it depends upon the given question. Sometimes it may be minimization, or sometimes it may be maximization. In our question, it is minimize z is equal to 6x plus 80y subject to the constraints. Understand, it is not always less than or equal to, it can be greater than or equal to also. 3x plus 4y greater than or equal to 8, 5x plus 2y greater than or equal to 11, and here also the quantities must be always non-negative. That is why x comma y should be greater than or equal to 0. Now we are going to see how the graph is plotted. Using GeoGebra, I plotted the graph, and our and you have to use the above method to plot the graphs, and I plotted this graph and this graph. Okay, this is going to be the feasible region. See, and we consider only this region. We should not come beyond the first quadrant. So only we are thinking of this region, only this region. Okay, only this region we are going to take. This is the region. This is the region. This region going unbounded. Okay, and the corner points are 8 by 3, 0. B is equal to 2, 1 by 2. That means these are the corner points. This is one corner point. See this corner point, and it went beyond that. One corner point will be there. So these corner points are noted. What are the corner points? 2.5. See, 2.5. 0, 11 by 2, and 0, 4. This goes to 11 by 2. Okay, 8 by 3, 0. See here. This is 8 by 3. 8 by 3, 0. Now, as the last step, what we are going to see is corner points. We make table. Corner points 8 by 3, 0, as in the previous table. B is 2, 1 by 2 from the graph. 2, 1 by 2. See, we calculate set. This is the cost. We calculate set, and here minimization. The question is that of minimization. So minimum means we have to opt the minimum value 160. But here the problem is that 160 and 160, two minimum values are there. No problem. You take 160 as the minimum value. 160, and you remember the procedure. Capital M stands for maximum value. Small m stands for minimum value. Here the region is unbounded. Now make it very much clarified. Small m 160. Okay. But at this step, you cannot judge that 160 is the minimum value. Listen very carefully. At this point of time, you are not able to judge that m is equal to 160 is the minimum value. No, you cannot. Okay. You have to go for a verification. For this verification, what you have to use is this value you have to use. And 60x plus 80y is less than, not equal to, understand that, 160. In the previous graph, you plot this graph also. Okay, in the previous graph, you plot this graph also. So you plot this graph, which is with a dotted line and below or above half plane. Okay, so we have got a feasible region. We have got a feasible region. Now we got another region determined by this. You just check whether the first region and the second region has no common point or has a point. If there is no common point, m is the minimum value you can verify. So this is just plotted for the verification purpose. Okay, so in this question, if you work out, you can see that this graph here, that is 60x plus 80y less than 160, if you plot this graph and our feasible region, there is no common point. There is no common point, and hence the obtained minimum value is the minimum value. And that happens when these 2 points can be taken as the answers. But a food P and Q items are there, and this is not an ideal one because only P is used here and Q is not at all used. So it is better for the manufacturer or dietitian to opt this 2.5. But as per the the answer or our observation, both are giving the minimum cost. And which one they have to choose, that is their choice. Okay.